Hello everyone, hope you all are doing well. Today we will start our new topic, that is balancing oxidation number by ion-electron method. How we can balance oxidation number. Yes, day before yesterday in last video we just revised our topic, that was the number of assigning the oxidation number, and in this one we will move on to the oxidation number, how you balance that number in electron method. First of all, we have to observe the medium. Like in oxidation number, there are two types of medium. One is acidic medium and second is basic medium. Acidic medium, that is having H plus ion, and basic medium, that is having OH ion. If any medium have OH ion, it means it's a basic medium. If H ion, so it's acidic medium. Let's move further. There are total 7 steps to solve it. Like to balancing the oxidation number, there are total 7 steps. Let's move to the first step. Like we are writing here. Let me show. Okay, we are writing here NO NO3 minus 1 plus H2S, and here it will be NO plus S. Basically this is our equation, and on this equation we will put H plus, that means that it's an acidic ion, acidic medium. Okay, now let's move further. Number first point say that to assign oxidation number to each atom of equation. First of all, what we have to do, we have to assign the oxidation number to this each number of atom. So let me write this again, that is NO3. Now here is 3, and at the top here is minus 1. When there is a far away from the element, minus 1 is written, it means it's charge. But when it's written near, so it means it's oxidation number. So first of all, we will find the oxidation number of NO3. We know that the oxidation number of oxygen is minus 2, so we write minus 2 over here. Minus 2 multiplied by 3, it's 6. Now after that, 6 is here, 1 is charged. When we minus 1, 6 minus 1, remaining 5. Okay, how much remaining? It will remaining 5 over there. When 5 is remaining over here, so it means that we are having plus 5 oxidation number of nitrogen, because we having 5 total oxidation number, so nitrogen having none oxidation number, so it means we will take that oxidation number from nitrogen. It means nitrogen having 5 oxidation number. Let's move to the another. Like we are having we are having H2S. Like in H2S, as I told you, we will do cross over here, so S will come over here. H have positive sign and S have negative sign, so we'll cross it, so it's minus 2, sulfur having minus 2 oxidation number, and hydrogen have 1 oxidation number. After that we are having NO. On NO, we know that the oxidation number of oxygen is minus 2 and the oxidation number of nitrogen is positive 2. And talking about alon S, in previous assigning oxidation number, I told that when we are having a single element, we will represent it in a free state. When it's in a free state, so its oxidation number is always 0. So sulfur oxidation number will be 0. This is the first method to balancing oxidation number by ion-electron method, that we assign the oxidation numbers to all of these this equation. Now let's move to the second point. On second point, it says that to separate the redox, means to separate the oxidation and reduction. After assigning the number, we have to separate the reduction method and oxidation method from this equation. So we are making the two parts, number 1 part and number 2 part. Okay, in number 1 part we will write a reduction equation. Like we are having reduction equation, that is NO3 minus 1 minus 2 and plus 5. We will also write the oxidation number that we have done in our first point. Now its reduction will be, reduction means the gaining of the electron. So it's gaining of the electron from n plus 2 and O minus 2, from plus 2 to minus 2. Let me show you over here. Here is written that NO3, just wait. Here is written NO3 and NO. Here it means the reduction will be from positive 5 to positive 2, means it's gaining electron from positive 5 to positive 2. Okay, and secondly we are having H2S and S. This is our oxidation one. Oxidation means that we are having, so here we are having H2S and S over here, and it's a oxidation because it's moving from minus 2 to 0. Because on hydrogen, on sulfur, here we will just find out the sulfur, and sulfur having minus 2 and it's moving towards 0, means it's losing its electron again and again and again. Okay, so when it's losing its electron, means it's losing its electron, means reduction. Yeah, talking about reduction and oxidation, to talking about reduction and oxidation, here in oxidation method we are having S minus 2 and it's moved from minus 2 to 0, means it's losing its electron. Okay, from minus 2 it means it's losing its electron, it's moved towards 0, it's oxidation. And in reduction it's moved from positive 5 to positive 2, it means it's reduction because it's gaining of electron, and downward is oxidation, that is losing of electron. So now we did the redox reaction over here. We separate the both equation with in both terms, in reduction and in oxidation. Okay, in reduction and in oxidation. After that we are moving towards, we will move towards to balancing atoms in acidic medium. Now we have, in third point, we have to balance the atom. Acha, I missed one point over here that I haven't written. Total there are 7 points, but one point I haven't written, that was if it will be not in ionic form. First of all we will make this equation in ionic form, then we will move forward. If it is in ionic form, so we will leave that one step. Okay, the now moving towards fourth step, that two balancing atoms in acidic medium. Before balancing the atom in acidic medium, we are having three types of atom. One was other atom, second name is oxygen atom, and third name is hydrogen atom. First of all we will talk about other atom. In other of atom, we are searching in equation, we are using by a coefficient like 1, 2, 3. We are seeing these in other atoms. Talking about oxygen atom, likewise we are having oxygen one oxygen is equal to H2O, means one oxygen is equal to water. Likewise we are having equation that is CO. Okay, and here we are having CO2, and here we are having CO. Just now what will happen is C means carbon and carbon, these both are other atom because there is one carbon. It means we don't have the need of other atom, but we have a need of oxygen atom because here is O2 and here is just O. We are having one O oxygen, that is short. So what we'll do, at the place of, I told that one oxygen is equal to H2O, so what we'll do, we will add one O to be equal this both, like plus. Now after plus I will add one O, that is one O is equal to H2O. Here I have written H2O. Okay, but now again, now O and O, 2O, here is also 2O, but here hydrogen, but here are how many hydrogens? Two hydrogens over here. So what we will do, we will use hydrogen atom, that is the third balancing atom, hydrogen atom. In hydrogen atom, what we are doing, if any side there is a shortage of hydrogen, we are adding hydrogen to make this equation a balance. So we'll add two hydrogens over here, that is 2H plus CO2. Let me show you in another, on another page. Yeah, you can see over here what I did. I just add over here like I was having previously, I was having CO2 CO plus H2O, but H2O was short on the reactant side, so we add 2H to make it balanced equation. So these are the three types of atom that we will use to balance our equation that we are using from starting step. So here our equation was 4, previously our equation was NO3 minus 1. Okay, NO3 minus, I divided our equation into two parts as you already know, so we will just transfer it into two parts. One is NO3 and second is NO. We are having these two equation, means we change, we are having reduction, we are having reduction. So what we did, nitrogen nitrogen same, means other atoms are same, but here was 3 oxygen and here was 2 oxygen, 1 oxygen, so we add 2 oxygen over here, and that is equal to 2H2O. Now here are the 4 hydrogens, 2 multiplied by 2, but here was not 4 hydrogens, so we add 4 hydrogen over here. Now here we used three types of atom. One is oxygen atom, because here was one, 2 oxygen was short, and we are using hydrogen atom in reactant because 4 hydrogen was short over there. Okay, and other atom are equal. After that, now moving to its second part, that is H2S and S. Okay, here we are having 2 hydrogens. Here other atom and other atom, sulfur is the other atom, they both are same. 2 hydrogen is extra there. Okay, oxygen is not there, so it means it's equal, so we add 2 hydrogens in oxidation, 2 hydrogen to make this equation equal. After making this equation equal, we are having fifth point, that is balancing of charges. How we balance these charges? We balance these charges by electron addition, by adding electrons. But how we will add electrons? Let me clear you one thing, that whenever we are having reduction, okay, then we are having a sign on reactant side, like this is Na, sodium. Okay, and sodium is gaining one electron, while when sodium is gaining one electron, and here it will be Na0. Okay, it means that sodium is gaining one electron from in the reactant side. Whenever we are one electron in reactant side, it's reduction process, and whenever we are having it's on product side, like Na0, means it's losing its one electron, it means it is oxidation side. Okay, it's losing its electron, and here it's gaining its electron. Let's move towards our equation that we have to prove it, balanced it. So our equation was our equation was 4H plus. Okay, after that we are having plus sign, and here we are having NO3 minus 1, and here we were having, I am writing it down, that is we are having NO plus 2H2O, that we have proved by balancing an atom in it. Now we will balance it with charges. Okay, now what I will do, first of all, what I will do, I will see the electrons in it, like here is 0 electron in NO, here is 0 electron in it, so it means here are the 0 electron in product sides in reduction. Now let's move towards the reactant side. In reactant side we are having 4, here is written 4, so we are having 4 hydrogen here. Okay, and in NO3 we are having just minus 1, it means 4 minus 1 is equal to 3 electrons. It means total electron we are having 3 here. Now we have to make this make this reactant equal to the product side. So here is the 0 electron in product side, but here is a 3 electron in reactant side. So what we will do, we will add 3 electrons over here with the equation, that is 3, just wait, let me write it, that let me write it, just wait, I should write it short. Okay, so already 4, why is it not working? Oh, okay, already 4H plus was written over here. Now what I will do, I will just add 3 electrons in it, like 3 electron negative. Okay, it means it's just gaining 3 electrons. When here are the 3 negative electron, 3 positive electron, it will cancel it out and there will be the 0 electron on reactant side and 0 electron on product side. So this was our first step of the reduction side. Now we will take same as oxidation side to make it make it equal by balancing of charges. We will take H, just wait, we will take H2S into S plus 2H positive. Okay, now what happened that on reactant side we were having the we were having 2 electrons over here. Okay, no, we are having 2 electron over here and we are having 0 electron over here. Okay, now what we'll do, we will add 2 electron on this product side, because I told you that on oxidation side we are having every electrons on the product side. So I will add 2 electron over here. These are the 2 negative electron, 2 positive electron, both will cancel out and here will be the 0. It means 0 0 electron on both sides. Now we have balanced the equation by charges, both equations. Now let's move to the another point of it. Now move to the sixth point. Yeah, now we will move to the sixth point. After that it says that we will multiply each equation by a number so that the electron in both the partial equation becomes equal to the number. What it means, it means that in reactant side we were losing 3 electrons, okay, but in product side we are losing 2 electrons to make this equation equal. Now what we'll do, we will do cross multiplication in both, like reduction side will be multiplied with 2 and oxidation side will be multiplied by 3. Okay, so here we were having reduction side multiplied by 2, so we were having 3 electrons previously. Now it's 3 to the 6 electrons. We were having 4, yeah, we were having 4 hydrogen over here. Now we multiply with 2, it's 8 hydrogen. After that here will be NO3, just now we multiply it, so it's 2 NO3, here is 2 NO and here is 4 H2O. And now oxidation side multiply with the reduction side. So here we were having just H2S. Now we are having 3H2S because it's multiplied. Here is 3S. We were having 2 hydrogen, it's multiplied by 3, it's 6 hydrogen. We were having 2 electrons over here, it's multiplied by 3, it's 6 electrons. Now let's move to next point. Next point says that, yeah, our next point says that, just wait for a while. Next one says that add the two partial equations after cancelling the electrons. In the sum equation, cancel out and the species common to the both sides. It says that if after doing everything, if these equations are just cutting out or just cancelling out or just adding in another to make the equation balanced, so we have to do that. Just like we were having 6 electron in oxidation, 6 electron in reduction, we just cut it out. We are having 6 hydrogens in oxidation, 8 hydrogen in reduction, so 2 hydrogens are remaining and nothing is cutting more. So we will write 2, this one 2 NO3 here, this 2H here, this then after that we will just write the all the equation together, that we just split out into 2 parts now. One part that is reduction and second part that is oxidation. Now we will just mix it and make it one equation just. Okay, we will make it one equation. So after that 3S2S in reactant side, and after that we are having 2NO in product side, 4H2 in product side and 3S in product side. Now we have to check it out that is this equation balanced or not. So for that we will check out, so just give me 1 minute. Yeah, now let me check. Here we are having two nitrogens just, and here you can see we are having 2 nitrogen just. After that 3 multiplied by 2, it's 6 oxygen here. Okay, here is 2 oxygens on this here 2 and 4 oxygens in this one equation. 4 plus 2 6 and 6, it means equal balanced. Nitrogen we are writing here, nitrogen is balanced, oxygen is balanced. Now what is remaining? Hydrogen and sulfur is remaining. Here is 2 hydrogens and here 3 multiplied by 2, 6 hydrogens. 2 and 6, 8 hydrogens over here. Here is 4 multiplied by 2, directly 8 hydrogens over here. 8 hydrogens here, 8 hydrogen on reactant side. It means it's also balanced. Now just sulfur is remaining. 3 sulfur in this one equation, and here is 3 sulfur in this one equation. It means it's also balanced. Now it means that the reactant side is balanced as the product side, both are equal. These are the main 7 steps to balancing the oxidation number by using ion-electron method. Hope you understand these 7 points. You just have to remember these 7 points to balancing oxidation number by ion-electron method. If you have any questions, you can write your question in comment. I will reply you as soon as possible. Till that, Allah Hafiz. Thank you so much for watching the video.